Hi everyone. Today we'll be working on 1.2 functions, and we're going to learn how to find the domain of a function from an equation. Problem number 5 and problem number 6. The best way to find the domain when you have an equation is to look for exceptions. What can we not do? And two things we know that we can't do is divide by 0 or take the square root of a negative. Now we can do that one. We know that the square root of a negative is an imaginary number, but when we're asked to find the domain, they're asking us to find the domain in the set of real numbers. So we don't worry about imaginaries. What's the domain in our coordinate plane in the set of real numbers? We can only have 0 to infinity under the square root. All right, let's see how to do that then. How do I state the domain of this function? The domain means, hey, what can you input and get an output? What can I plug into this function to make this statement true? Can I plug in positive numbers? Sure. Can I plug in negative numbers? Sure. Well, then what can I not plug in? You know that the denominator cannot be 0. So you just set whatever's in the denominator not equal to 0 and solve for x. I know that 2x minus 1 cannot be 0, so if I add 1 to both sides and then divide by 2, I know that x cannot be 1/2. So then what's the domain? Everything except 1/2. Can you write that in interval notation? The domain would be everything except 1/2. I don't know how to write that in interval notation. Maybe I could draw a little number line to help me out. Here's my x-axis, and I know that 1/2, I can't have 1/2, but I can have everything else. Notice there are two intervals, and on this side is negative infinity, and to the right side, infinity. Now, does that help you state the domain in interval notation? I hope so. Let's go from negative infinity to 1/2, parenthesis because we cannot include 1/2. Then union 1/2 to infinity. Notice everything here is a parenthesis because we cannot touch infinity, and 1/2 is what we cannot input. If I input 1/2, the denominator will be 0, and there is no corresponding output. The domain says all the inputs that make the statement true. Let's try again with problem 6. State the domain of the function. Now, what do I know about radicals? I need to state the domain in the set of reals. So whatever is under the radical should be set greater than or equal to 0. Do I care about the -3 being multiplied by the radical? No. What about the 4 being added? Do I care about that? No, it does not affect your domain. That doesn't have any effect on what I can plug in for x to make this statement true. What can I plug in for x? Anything that will make what's under the root greater than or equal to 0. So I take x plus 7, set it greater than or equal to 0, subtract the 7 from both sides. So x has got to be greater than or equal to -7. Can you state that in interval notation? Yes, you can. The domain is greater than or equal to, so bracket, -7 goes all the way up to infinity. If you wanted to draw a number line to help you see that, you can. X is greater than or equal to -7. Notice there's one interval. I hope that helps understand how to find the domain of a function from an equation. See you next time.